Hi, in this video, I will be showing you problem number 30 of chapter 4 section 4. Find the limit, use L'Hopital rule if appropriate. If there is a more elementary method, consider using it. Limit is x approaching 0, 5x minus sine of 5x over 5x minus tan of 5x. As we normally do in limit problems, we will plug and play. If it doesn't work, then we will apply different techniques. If you plug and play the limit x approaching 0, so it's 5 times 0, 0, minus sine of 5 times 0, which is sine of 0, divided by 5 times 0, which is a 0, minus tan of 5 times 0, which is tan 0. So the numerator is 0, denominator is 0. It becomes an indeterminate quotient. Anytime we have indeterminate quotient, we'll apply L'Hopital rule. So we'll now apply L'Hopital rule to this limit. So it is 5x minus sine of 5x divided by 5x minus tan of 5x. So when we apply L'Hopital, we use the symbol H for L'Hopital. Then we are going to apply the derivative of the numerator over derivative of denominator. Limit is x approaching 0. Derivative of the numerator over derivative of the denominator. So it is now derivative of 5x, which is 5, minus, so we'll have to take the limit at the end of the computation. So 5 minus derivative of sine of 5x, which is 5 times cosine of 5x. So here we apply the chain rule. So outer derivative times inner derivative. Derivative of sine is cosine, but the inner derivative would be 5. So 5 times cosine 5x divided by derivative of the denominator. Derivative of 5x is 5 minus derivative of tan of 5x, which will be 5 times secant square 5x. We can factor the 5 outside on the numerator and the denominator. So it is 5 times 1 minus cosine of 5x divided by 5 times 1 minus secant square of 5x. So this 5 get cancelled out. So at this point we can plug and play. Even if you plug and play, it's going to be 1 minus cosine of 5x, which is cosine of 0, which is 1, divided by 1 minus secant square of 0, that will also be 1. Again at this point you get an indeterminate quotient. So here also we are going to apply the L'Hopital rule. So anytime you have an indeterminate quotient, you can apply L'Hopital rule. So we are going to apply the L'Hopital rule to this quotient. So it is derivative of the numerator is 1 minus cosine of 5x derivative divided by 1 minus secant square 5x derivative. So in this case, it's going to be limit x approaching 0, derivative of 1, which is 0, derivative of cosine of 5x, which is going to be, so you already have a minus, derivative of cosine, that would be a negative sine of 5x times 5 using L'Hopital rule, using chain rule, divided by derivative of 1, which is 0, derivative of, so you keep the minus in the denominator, derivative of secant square 5x, that is going to be 2 secant 5x times derivative of secant 5x, which is secant 5x tan 5x. Derivative of secant is secant tan. And also you have to consider the inner derivative, which is derivative of 5x, which is 5. So times 5. Times 5. So we get at this point limit as x approaching 0. So you notice on the numerator and the denominator this 5 can be cancelled out. So there is a positive sign on the numerator, negative, negative. there is a negative sign in the denominator, so it now becomes negative 1/2 times. Now we have to simplify these expressions here. So it is sine of 5x on the numerator. Then we have tan of 5x in the denominator, which is going to be sine x over cosine, sine of 5x over cosine of 5x in the denominator. So if you flip and multiply, that's going to be cosine of 5x over sine of 5x. Or you can consider this as 1 minus 1 over tan, which is cotangent 5x, which is going to be cosine over sine, divided by, and you're going to be left with secant square 5x in the denominator. So this makes us simplify these two. Sine 5x can be cancelled out. Now you can plug and play. So it is negative 1/2 cosine of 5 times 0, cosine 0 divided by secant square 5 times 0. That is going to be negative 1/2. Cosine of 0 is 1. Secant square 0 is also 1. So the limit value is negative 1/2. Hope this video helps.